Right now, moving through our solar system, there is an object older than the sun itself. Not older by a little, older by billions of years. Scientists have pointed some of the most powerful telescopes ever built directly at it, and what they've found has happened only twice before in all of recorded history. This is the third time humans have ever seen something arrive from outside our own solar system, not from Mars, not from the asteroid belt, from somewhere else entirely, around another star, flung across the galaxy for longer than Earth has existed, possibly older than most of the stars you can see tonight. It is called 3I/Atlas. It is passing through our neighborhood right now, and it will never come back. Not this year, not this century, not ever again. I am your name, and this is Norlam. Subscribe now because this story is still unfolding as we speak. To understand why this matters, you need to understand how rare it is. In the entire history of astronomy, humans have detected exactly 3 objects from outside our solar system. The first, in 2017, was Oumuamua, a name that roughly means scout, or messenger from far away. It had no tail, it tumbled instead of spinning, and it sped up slightly as it left in a way nobody has fully explained. Some blamed hidden jets of gas. A few, only half seriously, floated stranger ideas. It vanished before we could study it properly, leaving behind more questions than anyone could answer. The second, in 2019, was Borisov, a far more ordinary-looking comet with a visible tail and behavior that matched what scientists expected. It answered fewer questions than they'd hoped, almost as if the universe had shown them something extraordinary once, then handed them something familiar just to keep them guessing. Then, in the summer of 2025, a sky-scanning system in Chile called Atlas caught a faint moving dot. Within days, astronomers confirmed it, our third interstellar visitor. And almost immediately, it became clear this one was going to break every rule the first 2 had set. Here's the first surprise. Its path is not a normal orbit. Everything that belongs to our solar system loops around the sun again and again for billions of years. 3I/Atlas does not loop. Its path is what astronomers call hyperbolic, a straight line trajectory that bends only slightly around the sun before continuing outward forever. It is moving at roughly 58 kilometers every second, fast enough to cross the distance from New York to Los Angeles in about a minute. That speed alone told scientists something important. This object was never ours. It was only ever passing through, and this is the only time in human history it will ever be in our skies. Once it leaves, no telescope built by any future generation will ever see it again. Whatever data we gather now, with no second chance. It's worth pausing on how difficult catching an object like this actually is. Interstellar visitors don't follow a predictable schedule the way a known comet does. They simply appear, moving fast, usually faint, somewhere in the vast darkness of the sky. The Atlas survey system was originally built to scan for asteroids that might threaten Earth. Almost by accident, it also became one of the best tools humanity has for catching things that don't belong here at all. Once the object was flagged, astronomers around the world raced to confirm its path, and within days the picture was undeniable. This wasn't a rock from our own backyard, this was a visitor. There's also the question of size, and it's smaller than most people picture when they hear the word comet. Early estimates put its nucleus at somewhere between a few hundred meters and a couple of kilometers across, wrapped in a faint cloud of gas and dust that grows brighter the closer it gets to the sun. It is not a planet killer. It poses no danger to Earth. Its closest approach to the sun still keeps it well outside our own orbit. What makes it remarkable isn't its size or its threat level. It's simply what it's made of and how long it's been traveling to get here. The second surprise came from its chemistry, and this is where the story stopped being simple. 2 of the most advanced instruments on Earth and in orbit were turned toward it. The James Webb Space Telescope, capable of reading faint chemical fingerprints across billions of miles, and the Very Large Telescope in Chile, one of the most powerful ground-based observatories ever built. Both instruments split the comet's faint light into its individual colors, reading exactly what it's made of without ever touching it. What they found did not match anything native to our solar system. Every comet that formed here carries a signature built from the same raw material that built the planets and us. 3I/Atlas didn't carry that signature. Its ratio of carbon isotopes was noticeably different from anything local. Dr. Martin Cordner, who led the James Webb observations, put it plainly, this is like nothing we find in our own solar system. Researcher Binyang Opitom, working with the Very Large Telescope team, called it, in the truest sense of the word, an alien object. Not alien meaning life, alien meaning it was built somewhere else entirely by a different star, under different chemistry, and we were reading its ingredients from 90 million miles away. Think about what these instruments are actually doing here. They never touched the comet. They never sent a probe anywhere near it. They simply caught the tiny amount of sunlight bouncing off its surface billions of miles away and pulled apart that faint light like a prism, reading the exact fingerprint of the elements hiding inside it. That's the closest thing scientists have ever held to a physical sample from another star system without ever having to leave home to get it. The third surprise was the hardest one to sit with, because the chemistry didn't just tell scientists where this object came from, it told them when. By comparing the comet's composition to models of how different stars process elements over time, researchers estimated its age, not the age of its journey, the age of the material itself, and the number was staggering, somewhere between 3 and 11 billion years old, with some estimates reaching 12 billion. Our Sun is 4.6 billion years old, Earth is roughly the same. If 3i/Atlas sits on the older end of that range, it means this object was already ancient, already drifting through the galaxy before our Sun had even finished forming. Somewhere out there, around a star that may no longer exist, this exact piece of ice and rock came together and then spent billions of years crossing the empty space between star systems completely alone, completely unseen, until this year, when it happened to drift close enough for us to finally notice. Researchers believe it likely formed in the outer edge of a very old star system, possibly one shaped by a star older and cooler than our own Sun, in what astronomers call the thick disk of the galaxy, a region packed with some of the Milky Way's oldest stars. This is not an object that has been traveling for centuries. This may be an object that began its journey before our solar system was anything more than a loose cloud of dust. And if that's true, then everything happening on Earth right now, every war, every invention, every person who has ever lived, fits inside a sliver of time so small compared to this comet's journey that it barely registers as a rounding error. To really understand the scale of that number, picture it a different way. If you laid every generation of human beings who ever lived end to end, going back tens of thousands of years, you still wouldn't come close to a single billion years, let alone 11 or 12 of them. This object may have been drifting through the galaxy for a length of time that human history can't even meaningfully compare itself to. Entire stars have been born and died since this comet began its journey. Galaxies have shifted shape, and through all of it, this single piece of ice kept moving, silent, unseen, until now. And being alone that long leaves marks. Interstellar space isn't empty. It carries a faint, constant rain of cosmic rays, radiation streaming from exploded stars scattered across the galaxy. New research on 3i/Atlas suggests billions of years of that exposure have slowly altered its outer layers, reshaping its surface chemistry in ways no comet native to our solar system has ever experienced. Until now, almost everything we understood about comets came from objects that spent their entire existence safely inside the Sun's protective bubble. 3i/Atlas had no such protection, not for billions of years. Studying it is giving scientists their first real look at what deep space itself does to something over almost unimaginable stretches of time. That means every reading isn't just a record of where this comet came from. It's a record of everything that happened to it along the way, written directly into its surface, a multi-billion-year diary that no one thought to look for until this exact object drifted into view. Step back and think about what's actually happening right now. Telescopes across the world are pointed at a single small object drifting through our solar system, built from material older than our Sun, carrying a genuine fragment of a completely different corner of our galaxy. And we are reading it, not theorizing, measuring it directly, the way you'd check ingredients on a label, except this label was written before Earth existed. And there is something almost unbelievable about that sentence when you actually sit with it. A species that has existed for a few 100,000 years on a planet that has existed for 4.5 billion just managed to read the chemical history of an object that predates both of those numbers combined. This is also why the comparison to the first two visitors matters so much. Oumuamua was strange but gone before we could study it properly. Borisov was almost too ordinary to teach us much. 3i/Atlas gave scientists enough time and enough signal to actually study it properly, and what it revealed was more extreme than both. Older, stranger, more clearly different from anything that belongs here. Put the three side by side and a pattern starts to emerge. Each visitor has told us a little more than the last, and each one has raised the odds that what we're catching are not rare flukes, but the first visible edge of something far more common than anyone expected. There is still a lot we don't know. Scientists are still working out exactly which kind of star system it formed around, and exactly how its chemistry changed after such a long journey. Was it kicked out of its home system early, or did it drift free only recently in cosmic terms after billions of years bound to a star that has since changed or died? Was its surface shaped mostly by cosmic rays, or did a close pass by another star somewhere along its route reheat it and alter its chemistry more suddenly? These aren't small details. They're the difference between understanding this as a single strange visitor or understanding it as a genuine sample of what most of the material drifting between stars in our galaxy actually looks like. New papers on this object are being published as this video is being made, with teams racing to gather everything they can before it becomes too faint to study, because that window is already closing. 3I/Atlas is moving away from the sun, retreating back into the darkness it spent billions of years crossing. Every week it grows fainter. Every observation from here forward is one of the last chances anyone will ever have. Once it's gone completely, not for a lifetime, but forever. There is no mission being planned to chase it down. There is no future spacecraft that will ever catch up to something moving this fast on a path that only points outward. Whatever gets recorded in these next few months is the entire permanent record humanity will ever have of this object. And there's one more detail worth knowing. Astronomers went back through old archived images taken before 3I/Atlas was officially discovered to see if it had been caught on camera without anyone realizing. They found it sitting quietly in commissioning images from a brand new observatory called Rubin months before the announcement. Nobody was looking yet, so nobody saw it. It had already been photographed, hiding in plain sight before humanity knew to search. That detail matters more than it might sound like at first. It means our tools were already good enough to catch this object weeks before we even knew it existed. As telescopes like Rubin come fully online in the coming years, scanning the entire sky every few nights instead of relying on chance, scientists expect interstellar visitors like this one to stop being rare surprises and start becoming a regular, almost expected part of what we see passing through. There's also something quieter worth sitting with. Somewhere, billions of years ago, around a star we'll likely never identify in a system that may have already ended, this small piece of ice and dust came together with no way of knowing it would ever be noticed by anyone. It drifted for longer than we can properly picture, through darkness with no light and no destination, no gravity strong enough to catch it, no star warm enough to melt it, just empty distance stretching in every direction for what would have been, by any human measure, an eternity. And then, for a brief handful of months in 2026, it happened to pass close enough to a small yellow star with 8 planets, one of them covered in curious creatures pointing enormous mirrors in its direction, trying to read its story before it disappeared again. Of every path it could have crossed, of every star system scattered across this galaxy it could have drifted past unnoticed, it crossed ours at the exact moment we finally had the tools to notice. So what does this add up to? 3 visitors from beyond our solar system confirmed in less than a decade. Each one stranger than the last, each one teaching us something the one before couldn't, and this third one crossing our skies right now may be carrying material older than the sun that warms our planet, a physical fragment of a star system that existed long before ours began. There's a bigger question sitting underneath all of this too. If we've already found 3 of these in less than 10 years, simply by getting slightly better at scanning the sky, how many more are out there that we've simply never caught? Scientists studying interstellar objects now believe visitors like this one aren't rare at all. They believe our solar system is constantly being crossed by material from other star systems, and that for most of human history, we simply didn't have the instruments sensitive enough to notice. 3I/Atlas isn't the exception. It might be the first clear proof of something that has been happening around us the entire time, completely unnoticed until very recently. It came from somewhere we may never precisely identify. It formed around a star that may no longer exist. And once this narrow window closes, it vanishes into the dark, and no one alive today, and possibly no one for the rest of human history, will ever see it again. Everything we know about it right now, every measurement, every chemical reading, every estimate of its age, is the entire permanent record humanity will ever have of an object that has been traveling since before our planet was born. If you want to know the moment new data on 3I/Atlas gets published, subscribe and turn on notifications. And this channel breaks down real verified space discoveries explained simply, without exaggeration and without guesswork. Drop a comment and tell me which of the 3 interstellar visitors you find strangest, Oumuamua, Borisov, or Atlas. Because whatever the 4th one turns out to be, and there will be a 4th one, you'll want to already understand what you're looking at when it finally arrives. Thanks for watching.